Hi, I'm Yan Qi. I'm an ECE undergraduate, and in this summer I've been working in Computer Vision Lab in EE department. And my instructors are Professor Silvio Savaros and graduate Wonggong Choi. So in this summer, my project is about multiple target tracking with single minimally calibrated camera. And in this video, I'll briefly talk about this project. So here comes the question. First, what is video tracking? Video tracking is about locating one single or multiple objects over time within a common camera. And the object is to associate target objects in consecutive video frames. And this could be pretty hard when the objects are moving very fast relative to the frame rate. So it's actually a complicated work. And what can we do with it? So this technique has a variety of uses. Some of those are human-computer interaction, augmented reality, traffic control, video editing, and maybe you can use it with the artificial intelligence. So the robot can use the technique to help itself to locate the object and to move itself. And how to achieve that? So because the video contains a lot of data, and those data are about the appearance information, the size, the color, and other things. So the first we want to do is we want to focus ourselves on the target. So we want to extract the target out of the video sequence. And we divide the video sequence into a lot of single frames. It's like for every second we may have 20 to 30 frames, and usually. And the thing we want to do is the object recognition. It's the process that we track the target out of each frame. So for object recognition, we just want to distinguish the object out from the background. And in our project, all the targets are referred to the human beings. So we want to distinguish human from backgrounds. And the thing we are doing is we analyze each small part of each frame. And for each part, we analyze the color, the size, and the pose information to see if that part is very likely to be a human being. If it is, then we use a bounding box to annotate that area. So this bounding box is called the annotation or the detection for human being or for the target. So you can see on the picture that there are like 3 bounding boxes for a human being. This is a typical case. And the next thing we want to do is to select the best bounding box from all the row detections, because there are many bounding boxes, and some of them are just for the same target, and some of them are just not for a human being. So we need to select them. So in this time, we group the bounding boxes first, and we analyze them in a more detailed way. And we analyze their interaction with each other. So finally, we can determine which bounding box is best for the target. And you can see that in this example, only 3 out of so many bounding boxes are selected finally. The step 2 is to establish motion model, because the frame can only reflect a 2-dimensional world. And in reality, the world is 3-dimensional. So we need to restore the world and establish a motion model. So the things we are doing is to extract some ground features. The ground features are referred to those easily recognized features on the ground. So our assumption is that those ground features are never changed and they're fixed. So with the relative motion, we can analyze the motion of the human being and the camera, and we transform them into the real-world motion. And the drift are taken between successive frames. So the step 3 is to form correspondence. As I said, that for each target, it does not only disappear in one frame. It disappears in more than 1 frames in a video sequence. So we need to associate the same detection for the same, to associate all detections in different frames for the same target. And this is the thing for forming correspondence. And we just keep record of the motion information and appearance information for each target existed. And we use those information to make prediction in next frame. and we want to find the detection match for that prediction in the next frame. Once we find it, then we associate it with the target, and we update the target model with the new information. So this is the way to find the correspondence. And if there is no prediction match for that, then we consider it as a new target. So you can see that actually the two detections in these two frames are for the same man. So we use the same color bounding box to annotate that. And the step 4. Step 4 is just put everything together and try to draw trajectories for different targets. So we also draw the camera on the map, and the angle represents the camera side, and the different color spots are representing the targets, and the lines are representing for the trajectories. And we want to establish a 3D model, and we want to draw the trajectories in a more detailed way. And one thing to mention is that the camera motion is also changed, so the direction of the camera is actually keep changing. So, and because the camera is not stable and the detections cannot be perfect, and also if we have higher resolutions, then it requires much more time for processing. So actually, the result may not be accurate. So we may need to use some other tools to help us. So actually, we use the sampling method and statistics tools to help us. And with those mathematical tools, we can get better performance. And actually, now we can deal with robust cases. So next, I'll show you some short videos about our research. So you can see that in the right half is the map. So the right angle shows the camera side, and the colorful spots are just the target. And in the left side is the video sequence, and we can see that the colorful bounding box are representing the targets, and the same color represents the same target. So let's begin. So you can see that actually with the same color in the right half, these spots are also moving, and the camera is also moving, and the direction is changing. And we can also check that there are some red spots on the ground, and those things are the ground features. So they are assumed to be fixed because the frame is changing so fast. So it may be like disappearing. Actually, the tracking is pretty good, and this test gives us very good performance. Okay, so that's all. Thank you.